Okay, so let us get started. So first questions. Today we will learn JavaScript, right? So yes, but we still have the Hyperledger to cover, right? So we will finish cover ledger, the Hyperledger, and then we will start with JavaScript next week. So the reason is, of course, we have maybe half of the lecture on the Hyperledger, but I also have some problems on my computer making the JavaScript run. So normally what I do is I use this Rhino interpreter, which is like a console prompt for JavaScript and things like that. And since I have Mac and I think Java is support is discontinued and Mac, so it doesn't work. So I need to fix my interpreter for JavaScript. So that's why we will start from next week onwards. And so today we will finish the Hyperledger. So we have seen last week about Ethereum in detail, especially about the nodes and also about the gas and Ether, the semantics around Ether and all other things, right? So we have covered enough Ethereum to get started on the programming. So, but again, when we come back to the programming, again, if necessary, we will quickly recap some of the things which are needed for programming, right? So maybe we don't need to go through all the constructs of Ethereum. If necessary, we will pinpointedly look into some of the constructs like the gas calculation and also Ether calculation, those things. So my idea is to cover Hyperledger this week. Maybe you will not work with Hyperledger, right? So because again, you will look into this architecture. It is a bit complicated architecture, very, very complicated architecture. Until unless you are working in a company and your company want to use Hyperledger, it's a very, very complicated thing to work on the Hyperledger, right? On the other hand, if you look into the Ethereum or even Bitcoin, those kinds of cryptocurrencies, they have a pretty simple and easily understandable architectures. But Hyperledger, again, we will look into the future slides. It has a complicated architecture. Maybe the purpose is also, it has a different purpose than the other public blockchains, right? So we will focus on Hyperledger. And my intention for introducing Hyperledger is, of course, we could simply skip Hyperledger and we can move on to Ethereum because that is at least what we would like you to learn in this course, right? At least you should be able to program with program smart contracts using Ethereum because that is easy. That gives easy entry into the decentralized computing and the decentralized programming and things like that, right? So that is the main expectation for the course. But on the other hand, probably some of you might go and work in the companies, and maybe if you, for example, if you join as a blockchain programmer or something like that, probably you might need to work with Hyperledger. So it's also good to know the architecture, at least from the very high level perspective, and that gives you a good start. So that is the main intention, right? So again, Hyperledger is really complicated. We had a pretty good experience with it. So from 2019 to 2021, we had a big project called the Advanced Blockchain Project, which was funded by some research funding agency. And what we did is we built a blockchain and IoT framework using the Hyperledger. So it was a big, painful experience, you can say. Many times the things don't work because Hyperledger is promoted by IBM, or you can say it is main development agency behind Hyperledger is one of the main stakeholders is IBM. So they have their own implementation, and the open source versions they didn't work, and a lot of problems and things like that. So we used one version of the Hyperledger, I think 1.4 or something like that, and then we did a lot of our own custom coding to make it work. So, but let us briefly understand the main concepts behind the Hyperledger. and what type of use cases it will be suitable for it, and things like that, right? So as I mentioned before, this is Hyperledger is mainly meant for the company implementation. Like the big companies, they come together, they form a consortium, and then they will go for a consortium blockchain where the companies can participate and exchange data in a trustworthy manner. So that is one of the good use cases people can come up with, right? So Hyperledger is a modular approach. It follows a modular approach. What does it mean? So it has different components. Again, the main purpose is to use for the big solutions between the companies, especially for the business. So the main idea is they want to go with some kind of component or modular approach so that you can plug and play different components based on your requirement. So that's why you have several different components. So for example, in Hyperledger Fabric, this is the one which is the main central framework people use, or you can say this is one of the most used frameworks in the Hyperledger ecosystem. So it contains it is mainly meant for the permissioned blockchains, right? It is a permission blockchain with channel support. We'll discuss what is channel and things like that a bit later. And on the other hand, Hyperledger Burrow is another component, as you can say, another variant of the blockchain, which is mainly meant for smart contract kind of execution. So this is similar to like Ethereum smart contracts, where you can deploy the code, where you can deploy the business logic as a smart contract, and you can execute on it. Right? So that is the main purpose. So it also have a execution environment similar to EVM and things like that. So, and you have the Hyperledger Grid, which is mainly meant for offering solutions for the supply chain solutions, right? So this contains a lot of the custom heuristics, which are mainly meant for supply chain solutions, things like that. And Hyperledger Indy is mainly the decentralized identity management. So this is one of the popular thing coming up. So without delegating your identity to the company, so this is works in a decentralized manner. So you can have your identity and validated by different entities and things like that. So this is mainly made for the decentralized identity management. And you have the Hyperledger Roha, I don't know how it is called, or Iroha, something like that. And this is mainly for interacting with the mobile applications. And let us say that if you have if you want to develop a blockchain, which can run partially, not the whole blockchain, but it needs to have a light clients which can operate on the mobile applications. So this is one of the variants which you can do. And the difference between the Hyperledger Fabric and Hyperledger Iroha is that Hyperledger Fabric, you have the peer-to-peer network. So the communication going on between the peer network way. But in case of Iroha, it is more like a client-server architecture. So you have what is a client-server architecture? If you know the HTTP protocol, for example, if you are browsing an internet website, the behind the request is nothing but the HTTP protocol and client server architecture, right? So you send a request. Let's say that you are accessing a Amazon website. You are sending a request to the Amazon server. To a computer or a server located somewhere in the world with some IP address, and your request will be handled by the server, and the server send response to the client, right? So this is a typical client server architecture which we daily see in our interactions with the internet. And you also have the sawtooth, which is also permissioned, and it can support permission and permissionless support, and it also supports this EVM transaction, right? So, and then you have different varieties. For example, you can model and build blockchain networks using Composer. Explorer is nothing but some kind of visualization tool, or actually a dashboarding tool, which can explore the blockchain blocks and things like that. So, and some other kinds of things. So mainly Hyperledger is mainly meant for business blockchain for business, right? So basically, it's not. You can see the architecture is quite complicated, and maybe we don't know. It's is it too complicated or whatever it may be, but it has a very complicated architecture. Basically, the main purpose or the main design goals behind this complicated architecture is that they want to develop a blockchain that can work for the businesses, and businesses might have a lot of different requirements. So for example, shipping companies, they might have traceability requirements and other kinds of things, but on the other hand, financial companies like the banks and other kinds of things, they have a different type of transactions that are going on, right? So they want to focus more on the industry solutions, especially between different big businesses. So that's why it is mainly meant for the blockchain for business, people would call it as, right? So it's not meant for the public interactions and things like that. So normally you don't see any public blockchain using Hyperledger. Hyperledger is a permission blockchain. So that means a company or a consortium of the companies, they involved in developing a solution on the Hyperledger, and it is a closed network. You cannot simply go and interact with the blockchain, or you cannot see what's happening in the blockchain as well. You need permissions for it. So this is a permission blockchain, right? So on the other hand, if you take the public blockchains like for example, Ethereum or even Bitcoin. These are the public blockchains, even though anyone can join without any permissions, those kind of things. But on the other hand, here it is mainly meant for the interaction between a small group of companies or a small group of entities for their interaction. Again, it's shared, replicated. It follows the decentralization principles. You have peers, and data is replicated across the peer, and it is permissioned, most importantly, and it also has a ledger. And the ledger contains several components. It's not a simple ledger like the blockchain, the Bitcoin or Ethereum, because what you have in the ledger in Ethereum or Bitcoin is just blocks joined with some kind of linking mechanism, right? So here you also have a world state and other kinds of things. Let us go through them bit by bit. And feel free to ask questions. So it will be a bit of complicated architecture. So if you don't understand, maybe raise a question, we can discuss, right? So let me take a simple use case to understand, or you can say, let me bring up one of the popular use cases using Hyperledger, right? So I think in 2016 or something like that. So Walmart, Walmart is one of the biggest or largest supermarket chain in America. So, and maybe in some other countries like Canada and other places as well. So they have a pretty wide network and chain of supermarkets, right? Like they are represent all over the US and things like that. So what they did is they teamed up with IBM, and they build a solution for food trust. So let me go one step further and I come back. What is the challenge they are trying to solve? So Walmart has, of course, Walmart sells anything from food, basic food, to the weapons, right? So you can go to Walmart. If you are in US, you can go to a Walmart and you can buy a gun. So they also sell ammunition, guns, and other kinds of things. Of course, it's different story whether you can buy a gun. It depends upon which state you are and what kind of status you have and other kinds of things. But in some states, Walmart can sell guns to anyone because there is no restriction on it and things like that. So they have a huge amount of product range and things like that. So what they want to do is they want to use blockchain for the food. What is the reason? The main challenge they are trying to solve is whenever there is some outbreak of the foodborne diseases. So, for example, E. coli is a good example. E. coli is nothing but a bacterial outbreak. So normally it happens in the leafy vegetables and things like that. So, for example, cabbage and the cauliflower and other kinds, and I think also spinach and those kinds of leafy vegetables. So what happens is when there is a E. coli bacteria in those vegetables, so when people eat it, they become sick, right? Sometimes they also become fatal, and then it's like an outbreak. Let me give you an example. I think in Denmark and other European countries, we had this E. coli outbreak several years back. I think maybe 8 9 years back or something like that, and it has been there for 2 to 3 months because they don't know the source. So, for example, from which type of the source this E. coli is coming. So, because normally the supermarkets they get vegetables from different sources, right? Different countries and different sources. So, they identified that E. coli present in these vegetables and things like that, but they don't know where it is coming from, right? So that was one of the biggest challenge to control and to categorize everything. They have to populate the supply chain checks across all the supply chain. Let us say that if they are receiving spinach from 3 different countries, they have to enforce checks in all the 3 different countries because they don't know which source it is and stuff like that. So these kinds of things are quite common. And the biggest challenge is when there is an outbreak, it goes for several months or at least several days or several weeks and things like that, right? So Walmart want to use blockchain to solve these kind of food outbreak challenges, right? So what is the main idea behind it? So basically, here is the blockchain, right? So uh, basically, you have a blockchain where all the upstream suppliers are also participating. For example, in case of Walmart, let's say that some country is supplying vegetables, right? So then you have the all the information right from the source. So, for example, when the farmers are farming the vegetables and things like that, and then they will do certain quality checks. So, for example, if it is an organic food, they have to make sure and they have to prove that they don't use any fertilizers and things like that. So, all these kinds of checks are put onto the blockchain at the time of producing the vegetables or the source materials and things like that. And while transporting also, and you have some kind of tests, even whenever the food is delivered to the distributor and things like that, certain checks will be made saying that the food quality satisfies the standards of the current country and things like that. So all this information is also put onto the blockchain and things like that, and the traceability of the products is also put onto the blockchain. So that means you can easily track each and every the piece of you can say every basket of vegetables from where they are coming from and what kind of information they have. So for example, what kind of certificates they have and when people have tested and things like that, right? So this is like a track and traceability kind of mechanism, but this will also give you the transparency in the supply chain, right? So that's why what they did is they built this trust supply chain where the information will be put across different points. And let's say that if they notice, of course, they have checks everywhere, right? Like the food has to be tested for the quality, whether it contains E. coli and other kinds of bacteria and things like that. If certain things happen, then they will minimize immediately. So they will they will what they will do is they will discard that batch of vegetable supply, and so that it doesn't contaminate the wide amount of people and things like that. So this is a quite a big success story. So Walmart and IBM were putting these very good use case for Hyperledger, and then it was a big populous story and things like that. So basically, you have the same kind of thing, like the sustainable certification. So where you have to produce all the certificates and things like that. And since the material is put onto the blockchain at different intervals, so people can easily believe and things like that. So that is the main challenge it tries to solve. But they try to use it for 25 products initially. I think this was in 2017, 2018, they implemented a supply chain, food supply chain, and they immediately they tested it on the 25 products, especially the leafy vegetables, those kinds of things. And then they want to roll out this information, this blockchain to all the food chains and many other talks. So that was the main thing. So what is Hyperledger Fabric? So any questions so far? Okay, good. So what is Hyperledger Fabric? So it's a implementation of the blockchain technology that is mainly meant for developing blockchains for enterprises, right? So mainly for the enterprises. Again, here the focus is for the permission blockchains, right? So it is the Hyperledger is one of the very popular blockchain technology that is used for the permission blockchains. So that means you know the entities. It is not like a public blockchain where, for example, in case of Bitcoin, in case of old Ethereum networks, where you don't have any identities. So it's not like that. When you have a permission blockchain, you know the blockchain is only meant between different companies or the people who have the permissions. So nobody else can interact with the blockchain, or they can see what is going on in the backend and things like that. So this is mainly permission and mainly meant for permissioned blockchains and highly modular. So that means you have different types of pluggable and consensus. So for example, you can easily plug different kinds of the components, and they can easily make it work with one with the other and things like that. So that's why they went with a highly pluggable architecture. And it also have the membership services and the certificate services and other kinds of things. So it goes for the endorsement and validation, those kinds of things. And they also support smart contracts in all languages. So for example, you can use Java, C# and other kinds of languages. So they also support for smart contracts. And privacy, they have privacy. And the most important thing is there is no mining. Mining means there is no mining, there is no incentives for mining. Because remember, in the public blockchain, you provide incentives to the peers to do mining because they need some computational power. They need to spend their computational powers to verify the transactions and put them into blocks and maintain the blockchain, right? So since it's a public blockchain, so that's why you will make sure that the rewards, mining rewards and other kinds of things you need to pay. And that's why you have the cryptocurrency, and then you have some sort of the currency to benefit miners to behave honestly and maintain the network. But when it comes to the permission blockchains, you don't have that requirement because only you have a small group of entities. Maybe it's different companies or maybe different entities participating in a big business or something like that. But you know pretty much who is who, and they have permissions. So that means they might have different permissions, who can put a transaction, who can verify a transaction, and all these things. So this is very well specified, right? So that's why there is no kind of mine and native cryptocurrency in the blockchain. And one important distinction between the especially Hyperledger and other public blockchain is the public blockchains, they follow this one: execute, order, validate. What does it mean? So let's take Bitcoin, right? So whenever you have the transactions, you will have the transaction. So what the miners will do is they will execute the transaction, right? So they will execute the transaction, and when if the transaction is valid, they will put into the block, and then the block is put into the chain. So or you can release into the network, and then so the ordering happens when the block is made, right? So first execution of the transactions happen, and then they will be ordered using the blocks, and then there is a validation. What is the validation? So whether the block is accepted by the all peers or not, right? So that means even though you put a block into the network, it is not guaranteed that your block will be accepted by all the miners, right? So when the block is accepted by all the miners, and when they start pointing the downstream blocks to your block, then it is kind of validated. So This is the order which we follow in the normally cryptocurrencies or public blockchains. Right? First execution of the transaction happen, and then order and validation. And if whole this process is finished, and if the block is validated and accepted by all the nodes, then only the transaction will make it to the chain, right? But on the other hand, here in case of permission blockchain, because we don't have any scope for malicious behavior, the reason is if some node does a malicious behavior, we clearly know who it is, right? Because we have the node entities, we have the permissions, and then they can easily fix it. So that's why here you don't have this execute order, but on the other hand, you have the ordering of the transactions, and then execution happens later. And meanwhile, you also have endorsement step. We will come back to that a bit later. So let's look into the semantics of the Hyperledger, right? So first of all, it contains the ledger, blockchain, and world state, right? So these terms are a bit complicated and confusing as well. So in case of Bitcoin or Ethereum, you have the blockchain, which is nothing but all the blocks linked to the chain, right? So that is the, you can say, the world state. You can say the everything put together is the state which we have in the blockchain. But here you have a different kind of architecture. So let me go through it, right? So you have a ledger. Again, what is a ledger? Ledger is some sort of, you can say, a kind of linked blocks and things like that. So the same notion of the ledger, right? So you have a chain of blocks, which is normally, and some information, then you can call it as a ledger, right? So ledger is a very abstract concept. And what ledger contains is, it contains a blockchain, similar to the Bitcoin analogy, where the ledger is nothing but contains blocks with chaining between them. On the other hand, in Hyperledger, in addition to the blockchain, it also contains the world state. So what is the world state? World state is nothing but some kind of database that holds the current values of the set of the ledger states. So basically, it also contains some information in the form of a database. Of course, remember, this is not a relational database. It's some sort of a database where you store information. And why do you want to do that? Because in case of public blockchains, you have because they run in the trustless environment. So that means there is no trust in the public blockchain. Anybody can interact, and sometimes people are malicious and they try to bring down or hack the blockchain, right? But here it's not the case like that. Here, since it's a permission blockchain, you know all the entities. And so there is no scope, or at least the scope for malicious behavior is very limited. Even if something goes wrong, you can easily trace it back and things like that. So that's why, rather than validating the whole blockchain for figuring out what is the current values and things like that, so the Hyperledger comes with a architecture. You have a blockchain, which is nothing but a link of blocks, a set of blocks using this chaining to link them each other. And you also have a world state, which contains the state information, right? So the state information is replicated to the world state. Let's go a bit deep into the world state, right? So for example, we want to save information like this. So first of all, it's a database, you can say, not a relation database. The data is stored in the form of the key value base, right? So for example, here we have a information car1 and the value RD. So this is the version 0. So that means this is one key value pair, right? And the value, it could be simple data types. For example, in this case, just we are storing a string, right? But on the other hand, you can also store objects in place of the values. So in this case, you are storing some kind of a dictionary, right, with the different attributes, an object with the different attributes and things like that. So you don't have any kind of relational databases, I can say relationality between the data values and things like that. everything is stored as some kind of key value pairs. So that is what is the world state about. Again, the main thing for the world state is you can read the state information easily without need to validate whole blockchain, right? So in case of Bitcoin, so for example, if somebody wants to transfer money or if somebody wants to see if the transaction is valid or not, they have to go one step back and verify the previous transaction, right? So similarly, even in case of Ethereum, you have some kind of validation checks being done and things like that. So here it is more like you also have some kind of data store where you store metadata for easy retrieval rather than validating the whole blockchain and things like that. It's a kind of mixed architecture, you can say. A kind of mixed architecture between on one hand, the data store databases and then decentralized technology. And what is blockchain? It is more or less the same as what are the blocks in the blockchain? It is more or less the same as the blocks in the Bitcoin and Ethereum. So basically, you have some transactions pulled together. And remember one thing, the transaction means it doesn't need always involve money. It could be a piece of information which you put, or it could be a piece of information saying that this lot of the products have reached this destination. Information like that, you can put it as a transaction, right? So these are the transactions put into the block, and you have some metadata, and you have a header, and again, you have the same kind of hash linking between the hash pointers, or you can hash linking between the blocks so that you can easily verify if the information has been tampered on. So other than that, there is nothing much going on here. So you just have a blockchain which is containing nothing but a set of blocks with the linkage, right? So that is the only one thing. And why do you want to have it? Because this is the immutability information which is put into the which you can say that this is like an immutable transactional record, right? So all the information is put into it, and then this serves as the authority and the things like that. And then you have the peers. Peers is nothing but you can say nodes or something like that, which run the blockchain and things like that. So, and then you have the peers. So this is the nodes. You can say peer nodes, and you have the smart contract. We also call it as the chain code. So, for example, here you have the smart contract installed on all the peers. This is similar to the Ethereum. When you deploy a smart contract, it will put onto the network, and all the nodes, I can say miners, who done the mining, they will receive this smart contract and they will have a copy of it, right? So similar to that, here also you have the nodes, peers, and the peers will have the smart contract, and then you have a ledger, right? So again, ledger means you can have multiple ledgers. So let me get back to you on that. Yeah, so this is the multiple ledgers. So multiple ledgers and chain code. So for example, each peer can have different ledgers. What does it mean? Let us take the example of Bitcoin and Ethereum, right? In case of Bitcoin, what we have is we have a cryptocurrency, and we have the transactions about the cryptocurrency, buying Bitcoins and selling Bitcoins. So this is nothing but a transfer of money, right? So only one type of business happening there. So the ledger is only one ledger. We don't have any multiple ledgers. So everything is put into the blockchain. That is the whole thing is the ledger funds. In case of Hyperledger, each peer can have different ledgers. So for example, let me take this example, right? One ledger could be to keep track of the goods, for example, track and trace and other kinds of things. The other ledger could be for example, transferring the financial transactions or money transactions and other kinds of things, right? So different ledgers, basically, they abstracted the kind of business functionality they were. But each peer can run different ledgers. And you have the smart contracts, and the smart contracts are bound to a ledger. So what does it mean? So for example, if you have the smart contracts can only on one ledger, so they cannot bind you to different ledgers and things like that, because the code and logic is mainly with the ledger, not with the contracts, right? Any questions so far? Okay, so then let me quickly go through the architecture, right? So you have to understand three things, right? So you have some endorsement. Again, we have a slide with more details and things like that. And you have ordering and you have a committing, right? So, and then you have different pluggable components, as I mentioned before. For example, if you want to use the certificates, your digital certificates, then you can have you can easily plug in a external CA, or you can also have your own CA. Basically, this is nothing but generating public and private keys, right, with some information. And you can also have the membership services or access rights and things like that. And yeah, all of that, these things are pluggable components. And then what you have is you have one ordering service. What is ordering service? Ordering service is nothing but it orders the transactions and put into blocks. And who does this job in the public blockchains? It is the miners, right? So the miners receive the transactions and they pack them, they verify and they pack them into the blocks and things like that, right? So the ordering service is nothing but it is doing the job of mining services. So basically, it will receive the transactions and put them into the block. But before the transaction being sent to ordering service, there is one step, extra step here. We call it as endorser. What happens is, let's say that you have a client application which want to put a transaction onto the Hyperledger blockchain, right? So then what it does is it will send the transaction to the endorsement nodes. So again, there are three different set of nodes: endorsement nodes, commitment nodes, or committing nodes, and also the ordering nodes, right? So the first it will go to the endorsement nodes, and the transaction will be verified by the endorsement nodes. And if they endorse it, it will come back to the client, and the client will send it to the ordering service. And the ordering service will receive the transaction, and it will make some checks whether it is endorsed correctly by the endorsement nodes and things like that. If it is correctly endorsed and other kinds of things, then it will put into the block and release the block into the network. And it is the committing nodes which will look into the block, and then they will commit and they will maintain the chain. Right. So let us get back to this flow again. I will go a bit detail into that. Before that, first of all, let us try to think how the applications can interact with the blockchain. Right? So let's say that each ledger, or you can say each the blockchain, it will have two different things. One is the blockchain, and you also have the world state, which actually contains information about the state and the business logic, the state about the metadata about the business, current business state and things like that. So let us say that we have, there are different ways you can interact with the application. For example, you might be a developer who is creating smart contracts. Again, the smart contracts in the Hyperledger, they are written in chain code. They call it as chain code. Of course, you can use different languages to write chain code. So basically, you can deploy the smart contract on the blockchain, right? So onto the Hyperledger fabric, or you can also write client applications which can submit the transactions. So for example, in this case, the application is directly submitting the transaction. So that means there's already some kind of information need to put onto the blockchain. So this will be directly put onto the blockchain and things like that. Or you can say the client application may also invoke a smart contract. Right. So in this case, the client application is calling the smart contract, and the smart contract will put some information into the world state, and it will also put corresponding transaction into the blockchain. So these are the different ways you can in the client applications they call the blockchain and put information into it. And similar to the Ethereum and other kinds of things, smart contracts can call external events. So, for example, let's say that when you execute a smart contract, you can send information to an event, and it can emit an event saying that now this information has been put into the blockchain and things like that. So, all these things can be possible. Okay, so the Fabric ledger is maintained by each peer. So you have peers who depends upon the how big is the blockchain. You will have several peers maintaining the blockchain and things like that. And again, you have the blockchain and world state. And a sublet ledger is maintained for each channel, the peer giants. Hold on for a minute. I will talk about the channels. But imagine that there is a ledger, right? So, and basically, the way you write transactions is a transaction is nothing but read-write sets, right? So, set of information and things like that. If I go back here, so these are the, for example, these are the some kind of read-write sets and things like that. So information is put into, again, using key value pairs and things like that. So these are called the read-write sets and things like that. And you have the channel configuration, which can be also written to the blockchain and things like that. And they use two types of databases. So level DB, which is mainly for the simple key value store. But on the other hand, let's say that you have big files. For example, let's say that in case of, again, let me go back here. In case of the Walmart case, let's say that the farmer has uploaded a certificate, right? So he uploaded some kind of certificate saying that the vegetables are produced organically or something like that. Or it could be some kind of image or a certificate or a paper document scanned and things like that. So that kind of information is stored in the other database, Coach database. This is nothing but a document data store where you can store information in the form of the document. And it also allows for running complex queries and things like that. So yeah, it is basically the smart contract which decides what needs to be written to the world state and how the logic flows and things like that. Okay, so let's go into the detailed flow of how transactions are accepted and put into the blockchain and things like that. Right? As I mentioned before, we have three types of nodes. The committing peer. So these are the nothing but the peers who maintain the ledger and state, right? So they commit the transactions and they may hold smart contracts, right? So the smart contracts is nothing but a chain code, right? So there's some kind of business logic. We call it as chain code in Hyperledger. And I don't know what is the reason they introduced this chain code name, but it's nothing but a smart contract, right? So, and then you have the endorsement peer. So endorsement peer, as these are the specialized peers, so the transactions will be sent to the endorsement peer in the beginning, right? So this is the first point of entry. If a client application want to put information into the Hyperledger blockchain, so these are the specialized peers endorses the transaction by receiving the transaction proposal and responds by granting or denying endorsement, right? So these are the first points of checks which will look into the transaction, and then they will decide whether they should be endorsed or not. That means they should be permitted or they should be denied, right? So, and these will definitely have the smart contracts because the way they verify the transaction and things like that is using the smart contracts. So the smart contracts, they will always have the copy of the smart contract with them. And you have the third node, which is called ordering node. So basically, as I mentioned before, ordering node is just packing the transactions into a block and then releases it. So the kind of flow happens is first you have the endorsement node, and first endorsement happens and ordering happens and the validation happens. The validation is done by the committing PS and things like that. So this is how the flow works, right? So you have a client application. And the way the applications interact is you have the SDKs. They will call the APIs. So, for example, you might have the services running, and you can call this web service and push information, and so all that normal format of things happen. So let's say that when a client application wants to send the transaction to the network, right? Hyperledger network. So first it will send it to the endorsement peers. So we have three endorsement peers, E0, E1, E2, right? So they contain the smart contracts. So for example, in this example, we have two smart contracts, A and B. These are the two different types of smart contracts, different workflows for each process. And then we have an enforcement endorsement policy. So this is P is nothing but an endorsement policy. What it says is, let us take this endorsement policy. It says that E0, E1, E2 must sign, right? So that means here we describe the endorsement policy as saying that all the three nodes, you can say all the three endorsement nodes, they must sign the transaction. They must endorse the transaction, right? So in this case, let us say that the transaction is sent to the endorsement nodes. Endorsement nodes will verify the transaction according to the logic of the smart contracts and things like that. And then let us say that if the transaction is valid, and what they will do is they will execute the transaction, right? So because this is nothing but a smart contract, so they will execute the transaction when we get the transaction and things like that. So they will execute it. And what is execution? Execution is nothing but capturing the set of read-written data. So read writes data set. So that means the information is populated in the form of read-write data sets. So we call this as RW sets. Mostly it is in the form of anything what you written to Hyperledger Fabric is nothing but in the form of key value pairs, right? So basically, as I shown before, an example, you have the key and you have the values, and so like that you have a dictionary of key value pairs. And then let's imagine that the transaction is valid. Then what the endorsement does, the endorsement peers do is they will validate the transaction, they will put their endorsement stamp, and then they will sign it, and they will send back to the client, right? So the job of endorsement peer is to, of course, they maintain the blockchain and they have the smart contracts. That's a different story. They always have the latest, you can say the state of the Hyperledger Fabric and things like that. They're mainly meant for endorsing the um, transaction to the network, right? So this is the first step, which is introduced when you compare with the public blockchains. So first they will be verified by the endorsers, and then only if the endorsers endorse the transaction, and then then only it can be sent forward, right? So let's imagine that in this case we have a policy saying that all the three endorsement nodes have to sign, and let's imagine that all three endorsement nodes are happy with the transaction, and then they checked the transaction, executed the transaction, and then they put this endorsement signature and things like that, and the transaction is sent back to the client, right? So now the client will have three endorsements for the transactions, right? So then what he will do is he will send this transaction along with three endorsements to this ordering service, right? So this is nothing but like a miner which collect the transactions and pack them into the blocks. So even the ordering service will receive simultaneously the transactions with endorsements from the other services, right? Other peers and things like that. So the ordering service job is to collect all the transactions and pack them into the block structure. And then the next thing what happens is it will create a block, and then it will send the block to all the nodes in the network, right? So We have the endorsement nodes, and we also have committing nodes. The committing nodes are the you could say committing peers, and so the block is sent to all of them. And then what happens is, again, we have some kind of algorithms available for the ordering service. We will get back to that a bit later. So then what happens is each and every one will verify the block individually, both the endorsement nodes and also the committing peers. All of them, they will verify the block, and if the block is valid, and then they will put it to this chain, right? So they will add it to the ledger, and then finally the commitment is done, right? And when once the block is valid and it is added to the local store, you can say the local chain of stores and the local ledger and things like that, and the information will be sent back to the client. If the client is signed up for the receiving the events, so for example, let's say that this client is only signed up for events between E1, E0, E1, E2, and then it will receive all the three events. And you can also sign up for the committed peers and things like that. So basically, it will send information saying that your transaction has been validated, and now it is part of the block so and so. So now it is officially put onto the blockchain. Right? So that is the kind of the flow happens in the network. Questions, comments?
Students, do you have any questions? Okay. So, Professor, you can continue.
Okay. So yeah, this is the whole transaction flow, how it is made into blocks and things like that, right? One thing to stress is the block preparation happens in the ordering service, right? So it is the ordering service who make the block, and there is no kind of incentives, there is no competition, right? So here you should probably in a network you only have the one ordering service, or you can have maybe a couple of ordering services if to just make sure that fault tolerance and things like that. But on the other hand, you will only have one entity of the ordering service who understand how to put into blocks and things like that. So there is no competition, right? So there is no wastage of resources and competing, and because there is no money, basically. Let's look into the ordering service. Ordering service could be done in different ways. So the ordering service packs the transactions into block and deliver it to the peers, and the communication is happening through the channels, right? So what is a channel? I will get back to you a bit later, but let us look into what are the different kinds of options for the ordering service. So the ordering service could be like solo. If you say solo, this is for the development purposes. You will only have one node, and then you just send the transaction, and it will be packed onto it will be collected and packed onto the block and things like that. But on the other hand, in reality, when you have big business cases running, you don't have the solo ordering service node, right? So then what you have is you have some kind of fault tolerant consensus. So these are like you have a set of nodes participating in the consensus, and they receive the transactions, and then they will order the transactions and things like that. So there is a consensus mechanism going on. You can say the Kafka is a crash tolerance, fault tolerance consensus mechanism. You need minimum 3 nodes, because remember, based on the fault tolerance mechanisms, you at least sometimes nodes can be malicious and things like that, Byzantine tolerance. But here you focus on the fault tolerance and things like that. And there is also another consensus mechanism, Raft. So then you have a much more in-process consensus and no extra dependency, more decentralized. And it's a very, very complicated thing, a complicated consensus mechanism basically you have. And you have the channels. So this is a completely a kind of, you can say, abstraction. So what is a channel? The channel provides the privacy between different ledgers, right? So basically, when you have different ledgers, again, what is a ledger? So as I mentioned before, you can say that a ledger is for one kind of business function, right? Or you can say business entity or something like that. So let's take the simple case of the supply chain channel, which keeps track of the products, track and trace, and things like that. Let's other case is that we have a financial channel, which actually transfers money and takes care of the what you call financial transactions, right? So this channel is an abstraction at the very high level happening in the network. And let us say that you have two different companies, right? And let's say that we have a consortium blockchain, Hyperledger. And let's say that you have two different companies, they have different transactions and different information flowing through them. And then in that case, probably each company will have its own channel. Then the information is abstracted from the other participant companies. So then you get a privacy of your complete privacy of your information, right? So it's like a common big network where you have your own channel and your information does not cross beyond the channel. So channel is an abstraction for privacy between different ledgers and things like that. Ledgers exist in the scope of a channel, so and channels can be shared across entire network of peers. So nodes you can share the channels to different peers. Let's say that different if the peer node want to do something, and then you can delegate the channel with permissions and things like that. Channels can be also permission with specific set of participants, so who can make a transaction, who can look into a transaction, and these kinds of things. As I told you before, we have a pretty big use case here. It's called trade lines. So Musk is a world largest shipping company, right? So it's in Denmark. It's one of the largest shipping companies. I think it does business about container business around 60% of the world market or something like that. And Musk and IBM, they built this huge blockchain for shipping companies. It's called trade lines, right? So trade lines, and then the idea is that this is a consortium blockchain, and all the shipping companies, they can put information on the blockchain, right? So that is the main idea. And so, for example, if you have other shipping companies, why do they share information? So the architecture is like you have different channels for each company to put information on the blockchain so that they can expose this track and trace visibility to their clients and things like that. Finally, trade lanes is a big failure story because the other shipping companies, they don't want to participate in this blockchain because Musk has a lot of monopoly over the blockchain because they build it, and they don't. The other companies, they don't want to join, and then they had another set of blockchain consortium, something like that. So peers can participate in the multiple channels, and concurrent execution happens for performance and scalability. Right. So if it is a single channel network, let us take the simple example of single channel network. So you have the nodes. Here we have the endorsement nodes, right? Each endorsement node have one channel. So the channel here, and you have the channel is connected to the smart contracts. You have the smart contracts AB, and you have the same set of the channel across all the PS and things like that. And then everything is the communication is abstract that channel, and so all the channels are here we have connected to the network and things like that, right? So we have the endorsement PS. Let me take a bit complicated example, right? So in this example, we have two channels. For the sake of simplicity, we have the blue channel, we have the red channel, right? So this maybe the red channel is again, let me bring up my stupid example of these two business cases, right? One is the track and trace, the other one is the fintech case where you have the financial transactions, right? Let's say that this is a financial transaction channel, and this is a track and trace channel, right? So, and peers can have multiple channels. So, for example, E3 endorsement nodes, it has subscription to both the channels. So that means it receives the information from the nodes who are mainly subscribing who are mainly working in the red channel, and also with the blue channel. So you can see the smart contracts are tagged to the channel because they are part of the deployment, and they live on the channel, you can say, in a sense, right? Again, there is a confusion between what is channel and the other kinds of things. You can say that channel is some kind of the logical abstraction through which the communication is abstracted from the rest of the peers participating in it, right? Rest of the information flow and things like that. So in case of E1, E1 is only signed up for the blue channel. So none of the information about the red channel will come here, right? So that's why they have this kind of separation between different companies' information using different channel architectures and things like that. So, and then, some channels they mainly dedicate to one sort of the logic, and many other nodes can subscribe multiple channels and things like that. Okay, so this is the last slide. So, questions, comments, and things like that. Does each endorser have their own distinct MSP? What is MSP? Can you say what is MSP? Membership service. Yeah, it depends upon how you configure the network, right? Maybe let me go back here. Yeah. So it depends upon how you configure the network. So, but the endorsement normally, okay. Maybe let me put it like this, right? So you have the membership provider at the level of one network. Normally, you don't need a membership service provider more than one at the one network level, until unless you have different companies participating and different use cases or something like that, right? So then you don't need one membership, and then endorsers, all the endorsers will communicate with this membership service provider or something like that to get information and things like that. So no. Does each endorser have their own distinct MSP? No, its MSPs are not at the endorser level, but membership services are at the network level. So even in our blockchain, we only have we didn't use membership services at all because we thought that it is too complicated to have it, and we have 80 companies participating in the network, and then we just provided some access control information and things like that. So, but no, different all the endorsement services, they will use the same membership provider. If there is only one business business is in the network. You can have different scenarios. For example, if you have different companies also participating in the network, let's imagine that you have a hyperledger, big one hyperledger similar to Ethereum, right? And then let's say that all the small ledgers are putting information onto it, and then you will definitely you will have different types of membership services, depends upon the business and things like that. But hyperledger is mainly meant for you can say meant for a software between consortium of companies. So again, you don't let's say that you have a hyperledger blockchains, and most of the times they don't even expose outside their company boundaries, right? So it is not a publicly running, it is running only among the companies members, the membering entities, and they will validate it, right? Otherwise you will have a lot of cyber threats especially, and the companies, they don't want to have the headache. And sometimes the companies will also have the legal requirements. So, for example, in case of Europe, you cannot store the data of European citizens or any information related to European citizens outside the EU boundaries. So that means if there is a provider in the US, they cannot even ship the information to the US provider. So that's why there was a big issue with the big companies, especially Microsoft and Google. So all of them now they have the data centers in Europe where they store all the information within the EU boundaries and things like that. So like that, yeah. So it depends upon the use case and other kinds of things. Any other questions or comments? Trade finance channel on Hyperledger Fabrics. That's why I have went with separate map for tracing bank, beneficiary bank. Yes, yeah. So yes, definitely. Yeah, here is a question. Maybe I don't know whether you were able to see the chat, everyone or not. So probably you are able to see the chat, right? Yeah. One of the maybe let me put some reflections, right? One of the big issue here is since you have to maintain your own network. What is network? Network means you need to have few servers. And nowadays, of course, you can easily get it in the cloud and things like that. And so you need to have the servers and you need to configure the blockchain yourself, saying that which nodes will act as orders, which nodes will act as endorsers. All the setup you have to do it, right? So if you are doing on your own, or you can say if you are doing, if it is a company, if it is a consulting, IBM consulting doing or something like that, they systematic do, they will do. Otherwise, it's so complicated, and many times you don't need all the components it offers, right? So, for example, we never used certificate services. We thought of using certificate services, but we said, okay, maybe it's too much for the use case or something like that. Okay, so any other questions or comments? Otherwise, let's maybe call it a day and then let's meet in the next week. So I copied the slides and I will also copy the recording later today.
Any other questions? Okay. So thank you, Professor. I think the students,
Yeah. Good night, and then yes. Thank you.
Yeah. Good night, Professor. Thank you all.